Today we are going to talk about day 2 of 3.2, our linear functions. Yesterday I had left some notes on the board to help you a little bit with the worksheet. However, we'll get more in depth with that today. So today we are going to be graphing linear functions. For our warm-up, we are asked to find the range of the function y equals 2x if our domain includes the values 2, 3, and 5. Then we are asked to graph the function. So, how am I going to find the range if I know the domain? Might be better to review a bit more. Range refers to what kind of values? One of those. Y values. Range refers to our y values. So the domain refers to what? Our x values. So we're given a domain. We are asked to find the range. We are given x's. We are asked to find y's. How are we going to do it? Do what? Yeah, so one way to set it up visually would be to set up a chart. So if that helps, you could do that. 2, 3, and 5. Is this what you meant by a chart, Lydia? Okay, good. That'll help us organize it. But how are we going to figure out what goes in the bottom part of our chart by the y's? Plug in our numbers for x. Good. So first we have y equals 2 times 2, which is 4. So that's my first y value. Next, I have y equals 2 times 3, which is 6. There's my next y value. Last, I have y equals 2 times 5, which is 10. Questions about getting our range from our domain? Okay, now technically we could list our range officially with the curly brackets. What order would they go in? 4, 6, 10, least to greatest. But then I am also asked to graph the function. Now this time my function is just going to be certain points, and I would get those points from my XY table that I set up. So the points that I need to graph would be 2 comma what? 2 comma 4, 3 comma 6, and 5 comma 10. We all okay with these points coming from this table? We have to pair up the x's and y's. Take a seat. Now that we have our points, we need to graph them. How would I get to the point 2 comma 4? We go right 2 and then up 4 from our origin. How am I going to get to the point 3, 6? Right, 3 up 6. And the point 5, 10. Right, 5 up 10. Am I going to connect those?
Yeah.
No.
Why not?
Because they told us our domain only consisted of a few values, so our range only consists of a few values. If we were to connect them, we would be saying our domain and range include all those points in between them. It does not. If it's only certain points, we only graph those certain points. In our notes, we need to know that a solution of a linear equation in 2 variables is an ordered pair x comma y, and it makes the equation true. The graph of a linear equation is the set of points that represents solutions to the equation. So that's kind of like what we saw in the warm-ups with our domain and range that we were given. Sometimes the points are distinct, like they were in the warm-ups, just points, and other times they are connected. This slide talks about discrete and continuous domains. A discrete domain only consists of certain numbers. So if we're talking about only the integers from 1 to 5, that's just 1, 2, 3, 4, and 5. It does not include any of the numbers in between. So that's why they did not connect those points. It doesn't include 2.5. It doesn't include 3.75. Okay, it only includes certain numbers. Another example of that I'd put on the board yesterday was the number of cars sold in a month. Now, you cannot sell part of a car unless you work at a salvage yard. But if you work at a car dealership, you're selling whole cars to people. So you would sell 1 car, 2 cars, 10 cars. You would not sell 1.35 cars. Does this make sense? Only certain numbers. What don't we understand about it? Have you ever bought 1.5 of a car? Have you ever heard of somebody buying 1.5 cars?
I know, but what does that have to do with this? Like, what do you compare me to?
Discrete domains. Discrete can only be certain numbers. Jada. Generally, yes, it'll be whole numbers unless they tell you that they give you a specific domain that only includes certain numbers that are fractions. But a lot of the time, discrete domains would be whole numbers. Good question. Other questions? Okay, continuous domains include all values in some interval. So all the numbers from 1 to 5. All of it means anything between 1 and 5, including 1 and 5. So it could include 4.2. It could include 1.89. Okay, any and all the numbers. So that's why they put a line in between those points. The other example I wrote up on the board yesterday was the number of candy bars eaten on Halloween. Just because you start a candy bar doesn't mean you have to finish it. So it's possible that you only ate 2.5 candy bars or 2 3/4 of candy bars. Maybe you split one with your friend or gave your little brother a bite of it. Something happened where you didn't finish the whole thing. So it could fall anywhere in between. Questions about the difference between discrete and continuous? Anybody need more time with this slide? Okay. Is the domain discrete or continuous? Explain. So you might want to copy this down. The input or the x values would be number of stories, meaning like floors in a building. We're not meaning books. Number of stories or floors of a building. And the output is the height of the building given in feet. All right, so do we think this domain is discrete or continuous? Does it only have certain values or can it have lots of different values? What do you think, Annabelle? So on this, I would think about Jada's question about whole numbers or not. So do we think that we could have 2.5 floors of a building? Not usually, right? Usually if you like you're on an elevator, think about it as being on an elevator. You can go to the first floor, to the second floor, to the third floor. You don't usually see a button for the 3.5 floor. Does that make sense? We can only have certain numbers, which makes this what? discrete. This is going to be discrete because x can only be certain numbers. And if this table represents the whole building, then this building only has 1, 2, 3 floors, and then we're done with it. Questions about why this is discrete? All right, next one. Find the domain of the function. Determine if it is discrete or continuous. I would agree that A is discrete. What's the difference between the pictures on A and B? Okay, whether or not it has a solid line. On A, we do not have a line. We only have points. So on A, it's going to be discrete. And if we list out our domain, it's only going to have certain numbers. What numbers did they use for x? So we can see a point at 6 on our x-axis, so 6 is one of them. Good, so James just listed them all out. I'm running out of space because we're going backwards here. 2, 1, and 0. So we have an x value up here, and then at 1, 2, all the way over until we get to 6. We do not see a point for, let's say, 1.5. Okay? So we only have very specific values. If you had wanted to list out all of your points first and then find your domain from that, like we did last week, you could do that. We have a point at 0, 6. We have a point, sorry, that's not curly braces. 0, 6. We've got a point at 1, 5, 2, 3. So I'm just listing out those points, and that's where our domain came from. That's something we've practiced before. Do we have questions about it? All right, letter B. Is that one going to be discrete or continuous? Continuous, because it has that solid line there, which means our domain can come anywhere from that. So there are lots and lots and lots of points. Remember that this is why we can't use curly brackets when we list the domain, because there are so many points that exist there. So instead of using curly brackets to state our domain, what do we have to use? Think back to last week. We did this several times. Inequality symbols. Very good, Lydia. We need to use our inequality symbols. Since we are just doing domain, I'll just list out the x. They didn't ask us for our range. What is the smallest x value that we have? 0, and the largest one is 6. So it goes from the same place to the same place, 0 to 6, but this one includes everything in between. This one only included the whole numbers. Not a whole lot different from what we've been doing, but we have to decide discrete or continuous. Questions on example 2, A or B? Okay. All right. For example 3, I would make sure that you have the function written down. Y equals 15.95x. This linear function represents the cost y in dollars of X tickets. So next to that function, or off to the side, you might want to put that y refers to cost, and that X refers to tickets. Each customer can buy a maximum of 4 tickets. Find the domain of the function. So domain refers to what? X or Y? X. So if we are finding the domain for this, domain refers to X. In this problem, X represents what? Tickets. So I have to think, how many tickets could I buy? What is a possible number that I could plug in, or a possible number of tickets that I'm allowed to buy? We can buy 4. That says you can buy a maximum of 4 tickets. So you could buy all 4 tickets that you're allowed to get. But what if you don't need 4 tickets? Then how many could you buy? You could buy 3. What if it's just you and your best friend going? You'd only need 2. What if you're going by yourself? What if you hate the museum and you don't want to go at all? 0. These are the possible amounts of tickets that we could buy. We cannot buy 2.5 tickets to go to the museum. Okay, we have to buy our tickets in whole number quantities. So is this domain discrete or continuous? Discrete, because they have to be what kind of numbers? Whole numbers. Okay, so they have to be whole numbers. They can only be certain numbers. You can't buy fractions of a ticket. Next, it says to graph the function using its domain. But I cannot graph only on a domain. What do I need to find before I can graph it? I need to know the range of it. In order to find the range, what am I going to have to do? Plug in my X values. So whether you want to set up a table or whether you want to just start setting up your ordered pairs, it doesn't matter to me how you set it up, but you better show me what it is that you're getting for your range. Okay, so we have to plug in 0, 1, 2, 3, and 4 for X, figure out what we get for Y. Okay, if I buy 0 tickets, how much money did I spend? $0. So I could go ahead and plot that point at 0, 0. For the rest of them, we are going to have to decide on a scale for our range or our y-axis, so we'll hold off on graphing till the end. If I buy 1 ticket, how much money did I spend? I spent 15, not 18, $15.95. If I bought 2 tickets, how much money did I spend? $31.90, I agree. What about for 3 tickets? I think you're close. 47 what? So we're taking $31.90 and adding how much to it? $15.95. So $47.85. Okay. And then what about for 4 tickets? I think you're close. So it's like taking 2 times 2, so we could take $31.90 times 2. And that should get us to $63.80. Now, am I going to want to count by count by ones on my y-axis if I have to go up to $63.80? No, that is not going to work for me. So on my x-axis, I'm going to spread out my 1, 2, 3, 4 a little bit. Along my y-axis, let's see, we could count by, probably by tens would be good. 10, 20, 30, 40, 50, 60, 70 up there. So I'm not labeling every single one because that's going to get really cramped. You can choose what your scale is. You just have to let me know what you decide for it to be. So if you want to count by something else because your graph paper is bigger, that's fine. This is what I'm going to count by. Questions about setting up your own scale? Okay. So we already graphed our point at 0, 0. Next, I have to graph a point at 1, 15.95. Now, I agree that's going to be a little tricky, but if I'm counting by tens, where would 15.95 be in between? Between 10 and 20. Probably just a smidgen closer to the 20, but really just in between 10 and 20. All right, at 2, I'm at 31.90, so I'm going to be in between which 2 numbers? Between 30 and 40, but probably a lot closer to the 30. At 3, I'm at 47.85, so I'm going to be between which 2 numbers? 40 and 50, but probably a little closer to 50. And at 4, I'm at 63.80, so I'm in between 60 and 70, probably a little closer to 60. Am I going to connect those? No, we said it was discrete already. You better not connect them. Questions about finding our domain, deciding if it's discrete or continuous, or graphing the function? Okay. Next one. A cereal bar contains 130 calories. The number C of calories consumed is a function of the number B bars eaten. So first we have to decide if we think that this represents a linear function. Let's first write a function. So we have to decide what's dependent and what is independent, which it's been a minute since we've done this. Which variable is independent? Which one do we control? Dominic, what do you think?
X.
Yes, generally X, but in this case...
It's Y.
Nope. In this case, they gave us a C and a B. Do we control the calories or do we control the number of bars we eat? Number of bars we eat. So that means that the calories is dependent and the number of bars we eat is independent. So when we set up our function, dependent equals Now this time I'll just kind of lead you there. How many calories per bar are we getting? 130. And if it's per bar, what operation do you think that means? You get 130 calories for every bar you eat. You're close. Further away. Multiplication is the one related to division. So we take the number of bars we eat, we multiply it by 130. That's how many calories we've consumed. Now, if you would rather set this up with y equals 130x, that's fine. They used c and b this time. But if you want to keep it x and y, we still identified our dependent and independent variables. Do we think that this is going to be a linear function? Think back to our notes from not Friday, Thursday. I see some people shaking their heads yes. I would agree, this is linear. X is not in an exponent. X is not in a denominator. X doesn't have an exponent. Do we remember all those things that made them non-linear? So this one is going to be linear. Yes, all we're doing is multiplying to x. Just multiplying. So it will be linear. Jada? Gotta wait till notes are over. Find the domain of the function. Is the domain discrete or continuous? Now on this one, when we talk about our domain, is it just going to be whole numbers? If you start eating a cereal bar, you have to finish it. No. This kind of goes back to the whole candy bar thing. It's like the same idea. Just because you start it doesn't mean you have to finish it. So when we start thinking about what our domain would be, what's the least amount of cereal bars you could possibly eat? How many? 0. None. You could eat no candy bars at all. Could you eat negative candy bars? No. So 0 is the lowest we could go. Now, assuming that we just have all the cereal bars in the whole wide world at our disposal, is there a maximum amount of cereal bars that we could eat? No. We could keep eating cereal bars until they have to put us in the ground, right? We could just keep going and going and going. So we can eat all the cereal bars we want, but we can't eat less than 0. So what this means is that x is going to be greater than or equal to what? Our bars has to be bigger than or equal to 0, the lowest amount that we set. I'm not putting something on the other side of that because there's no limit on the other side. Does that make sense? We could keep eating and eating and eating for the rest of our lives if we liked cereal bars that much. Questions about that? Now, by this time, you should have decided, is this discrete or continuous? Continuous. Because we could eat fractions of bars. It's not just specific numbers. Questions about this before we try to graph it? Now, when we graph this, we of course are not going to be able to graph every single point, but we can graph a couple points to help us out. I would recommend starting with like 0, 1, and maybe 2 for your x values. If I don't eat any cereal bars, how many calories have I consumed? 0. If I ate 1 cereal bar, how many calories? 130. If I ate 2 cereal bars, 260. Now this is not all of the values, but this will get us enough to make our line. Again, you have to choose your scale. So I'm going to choose to count by 50s this time. 150, 200, 250. Okay, we've got our point at 0, 0. My next point's at 1, 130. So that's going to be a little below the 150 mark. My next one's at 2, 260. So that's going to be a little above my 250 mark. Because this is continuous, what do I want to do with those points? Do what? Add a line that goes through them. Does it need to stop at this point? No, because we could have kept going. So our line is going to go through those points all the way to the top of the graph and put an arrow on it. We could keep consuming more calories if we keep eating more cereal bars. All right, the linear function y equals 1.25x represents the cost, y in dollars, of x bottles of orange juice. Again, I would maybe label your equation with cost for y and bottles for x. Each customer can buy a maximum of 5 bottles. Find the domain. Is it continuous or discrete? Does anybody have any ideas about continuous or discrete before we find the domain? What do you think, Hunter?
I think it's discrete.
I would agree. Why do you think that?
It's like the other one when you represent the cost of the y in dollars and cost of orange juice in x. So I can agree on that. I think you can add it up. Add the 5 in this one.
Good. So this is similar to the museum problem, right? Is that what you're saying? So this one's similar where we can buy up to 5 bottles. On the last one, we could buy up to 4 tickets. So if we're talking about our domain, we're talking about how many bottles we could possibly buy. Bless you.
Thank you.
How many bottles could we possibly buy? 5 or less than that, like 4 or 0 if we don't like orange juice at all. You cannot go to a grocery store and tell them that you want to buy half a bottle of orange juice. They won't let you do that. You got to buy the whole thing even if you don't want all of it. Do we have questions about that? Okay. So this one again was discrete because we could only use certain whole number values. Before we graph it, we need to know what our range is. So again, we are going to plug in our domain and find our range. 3, 4, 5. If I don't buy any bottles at all, how much am I spending? Nothing. If I buy 1 bottle, $1.25. 2 bottles, $2.50. 3 bottles, $3.75. 4 bottles, $5 even, and 5 bottles, $6.25. All right, we go to graph it. Again, I'm going to space these out a little bit. 4 and 5. Let's see. How many do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 12. I think I've got enough that I can count by 50s. So there's $1, $2, 3, 4. Oh, I might be a little over. That's fine. 5. So up here is 6. So I'll make just another. That'll be 6.5 way up there. You might be able to fit it better on your graph. All right, first point, 0, 0. That's easy. That's at the origin. 1, 125. That means I'm in between $1 and $1.50. 2, 250. That one should be easy to mark on here. 3, 375. That's going to be halfway between $3.50 and $4. 4, 5. That one again pretty easy. And 6, 625. Sorry, 5, 625 is going to be just a little teeny bit off of our graph. Now these all fall in a straight line, so should I draw a line that goes through them? No, because we said that this was discrete, meaning no line, just points. Questions, concerns about these? Okay. We will save example 6, and I'll go ahead and put homework up on the board. We've got numbers 3, 4, 27 through 37, odds, and 44. Some of these may ask you to graph, so you could use the graphs on the back of your notes graph paper, or you may grab one additional graph paper on your way out. However, I need graph paper for the rest of my classes. You will not need more than one additional, so do not take more than one. If you have your own graph paper you want to use, that's also fine.
Just one more day.
There's a 3.1 and a 3.2, both from yesterday.
You can't erase my name. I already took my test today.
I will erase it when I get it back.